All right, welcome to the Unit 6 lecture, Chapter 9 on forecasting. It fits really well in with where we've come from. It's a key item in operations management, and it fits well as we prepare to talk about inventory management in the next unit coming up. So, a good time to get this out of the way. I'm going to cover some overall kind of perspectives on forecasting, some approaches, techniques, and methods. I'm going to kind of show when each of them work best. I'm not going to solve them in this because you can use the solve problems, and I'll put additional videos where I have them available to show you actually calculating some of the individual ones. But I will get into the calculations for forecast error because there's just 6 of those and they all kind of fit together really smoothly. So let's dive in here and kind of get our heads around forecasting. So as we step in toward forecasting, we hit this topic, and the book doesn't use this term, but they call it demand management. But what it really is called is demand shaping. And so demand shaping is when we realize in our business that there's ebbs and flows to the volumes that we encounter. But we know, and we'll talk about this in the in Unit 8, is that our operation works best when our volumes are consistent. And so when we see that we've got ebbs and flows, then there's things we can do in management decision making that can help fill in those drops and move some of those peaks over into the low areas, because I don't want to have to work a ton of overtime and then lay people off, and then work a ton of overtime and then lay people off. So we want some just consistent operating, and that's called demand shaping. So it's really talking about how do we influence our customers to behave in the way we want them to rather than the way they want to behave. So we might do that by offering complementary products. So we might say, well, if you come in for coffee, but why don't you get a dessert with it, or why don't you get a cup of soup to take home for later, so we can increase our sales volume midday in our restaurant by adding things on to something that a customer might be coming in to get anyway, and matching those together. And it might be something where we sell washers and dryers together, and we might sell jackets and pants and things like that. So complementary products. So getting that add-on sale. Promotional pricing, that's what it is. It's a sale. We're saying, hey, between the hours of 1 o'clock and 4 o'clock, we'll give you half price shakes. If you remember dealing at Sonic, Sonic used to have great deals in the afternoons and evenings for products so that they could increase sales in their non-peak periods. Then we can pre-schedule appointments. We can kind of push customers to come in at a certain time and not others, so we don't get overloaded at one time and underloaded at another. So we may only allow appointments like maybe an accounting office, a tax office, where we want to get people to come at certain times. Reservations, good old open table and Resi, requiring reservations, so we know that we won't have people standing in a line outside the door of our restaurant at 6 o'clock, but at 5 o'clock no one's there, or at 7:30 no one's there. People will be able to look at the reservations and know when they can come, so it keeps our load balanced. And it pushes people. If you think about a reservation, you say, oh, I really want to eat at 7, but oh, the best reservation is 7:45. Okay, I'll come at 7:45. So they can use these services to help push us into different places. This one's a little trickier. If you're into marketing, you'll know about customer segmentation. And this is about revenue management. And so the potential to say, well, some customers earn us more money than other customers, so we'll give them special pricing or special deals or loyalty programs to get them to do business with us at different times. So it takes a lot more planning and breaking your customers into groups and understanding what motivates each of those groups. Allowing backlogs. So backlog is not a bad thing. We'll talk about the bad thing in a minute, but backlogs mean that we tell our customers right up front that it's going to take 6 weeks to deliver their order. So if you're ordering custom furniture or you're ordering a car from the manufacturer, they'll give you a 6, 12, 18-week delivery time. Carpet sometimes will be that way. So household finishing and things. And so what that does is it allows me, the business owner, to take these orders in advance and know that I've got maybe 6 weeks to deliver that order, but I see that I've got a low period coming up next week, and I may actually produce that backlog earlier, again, to keep my volume in my business consistent. I can use backlogs to fill in low spots. and then potentially even deliver early to the customer. That's not the same as back orders and stockouts. Back orders and stockouts are the bad thing. That means that you did a terrible job at forecasting because your customer came in and they weren't able to get what they wanted to purchase. And so they ordered something and you say, oh, that's on back order. That'll be 2 weeks till we'll send it to you. Or like we all experience when we go to Target or Walmart, we'll go in to grab something and we get there and the shelf is empty. That's a stock out. Those are the bad things. Those are the sign that you're not doing a very good job in your forecasting and planning. So which ties right into what is forecasting? And I use this definition: making a prediction of the future that can be used for planning purposes, inventory, staffing, facility size. So forecasting can be used to, I say these two things: plan the system. So we're going to need forecasts of how many classrooms we need in the building, how many tables we need in the restaurant, how much oven space we need in the restaurant, how much production equipment we need in the manufacturing facility. So we need to do forecasting in order to plan the system, to build the right size location, to set it up in a way that it'll handle that volume of customers. We also need it to run the system. So plan the system and run the system. So in order to make our day-to-day decisions about, well, how many employees do I need to come in on this shift? How many of this product do I need on the shelf? How much meat do I need to order? How much lettuce do I need to order? All of those operational day-to-day decisions also come under forecasting. So forecasting can really be a powerful and necessary tool in business and particularly in operations management. So first thing, there's two big decisions we need to make. We need to decide what to forecast, because forecasting takes time, it takes energy, it takes data. You got to sit there, you got to do it, you got to then look at it and decide what to do with that information. And some things you just don't bother forecasting. You just order a bunch of them and hope they don't run out, or you just let them run out and then you quick go on Amazon and order them. That is not forecasting. That is running by the seat of your pants. Second is the level of level of aggregation. I'll tie these together. Level of aggregation. So think about this. The bigger we aggregate means to put things together, look at it from a bigger picture level, the easier it is to forecast, the more accurate our forecast is. So if Kean University said, forecast how many students are going to come to Kean University next fall, that wouldn't be too difficult to forecast because we've got many years worth of data. And there's economic trends right now that we could factor in. And so we could probably come up with a pretty accurate forecast of how many students will come to Kean next fall. That's a high level of aggregation. Or how many students in New Jersey will go to college. That's an even bigger aggregation. And so your accuracy, you can probably be within like 2% of being dead on when it comes to accuracy. But when you get smaller and you drill down, your accuracy really gets less accurate. So if we instead of saying how many students are going to go to Kean, we say how many students are going to take operations management in person on Mondays at 1 o'clock in the afternoon. That's a very drilled down specific forecast. And that's really hard to estimate because some students may take Monday at 1, some may take Tuesdays at 3, some may take online, some may take Thursday evenings. And so it's really, individual students could have special needs of going all over the place. And so your level of accuracy starts to go down, and you may be off by 10 or 12 or 15%. And that's what we find when we forecast our classes here. We'll find that at the class level, class and time, we're kind of off a little bit. But when you look across all of the classes that we schedule in the College of Business, then we're probably only off by like 5% or so. So the more you aggregate, the better your accuracy. The smaller, but the challenge is you really need those detailed, drilled down to make decisions. You need to decide, how many sections am I going to schedule of MGS 3100? You've got to be able to forecast at the appropriate level to make your business decisions. So the level of aggregation varies depending on what type of decision you're needing to make. The other question that ties right in that is unit of measure. So whether we're looking at courses or students, let's look at another one. Let's look at a business, and we could say, how much business is Starbucks going to do each day? We'll forecast that, and let's say that's $10,000 worth of revenue per day here at one local location. That's a lot of coffee, but let's just say it's 10,000. That might help you make decisions about how many tables to put in the restaurant, how many parking spaces you need, how many staff need to be on for a day. But it doesn't help you with how many cups to order. It doesn't help you with ordering cold cups versus hot cups. It doesn't help you with ordering different types of espresso beans. So the unit of measure is very important, and the unit of measure will vary depending on, again, what kind of decision you're going to make. So if you're reordering your cups and your supplies and your sugar and your cream, then you need unit of measure to be eaches. They need to be units. They need to be cups. Pounds of beans, so at the smallest level. And the other key to picking your unit of measure is you need to forecast in a unit of measure that people can actually use. Because if you go to your inventory person and say, oh, I'm planning on doing $10,000 worth of business tomorrow, well, the inventory person goes, oh, so, how many cups do I need to order? Oh, I don't know. So you got to choose the right unit of measure. And then once you have the answer to these two questions, you go back and say, well, what data do I have at that aggregation, at that unit of measure that I can use to do the forecast? So then you need to choose what forecasting technique to use, and here's some of the high-level ones. Judgment techniques. So that means we're not going to use data in its purest numbers form. We're going to use knowledge. We're going to say, well, based on my experience, a new Starbucks location in this zip code close to these businesses should do X amount per day. So those judgments, these forecasts aren't bad methods. They're just based on knowledge, expert opinion. We'll talk a little bit more of those in a minute. Causal methods are things where we can correlate things together. So when the temperature gets higher, air conditioner sales go up. That's a correlation. Regression allows us to go even a step further. If you remember regression from statistics versus correlation, correlation is one variable to another. So sales based on temperature, price to quantity sold, one-to-one relationships. Regression allows you to put multiple variables in to predict your quantity sold. So you could use temperature, economic condition, I don't even know, month of the year, phases of the moon, whatever multiple things you want to put together, and regression will allow you to blend those together into your forecast, how many units you're going to need in the future. Time series method, these use some fairly basic mathematics, addition, subtraction, multiplication, and the chapter hits in these and does some great demonstration on this. This is where we talk about things of moving average. So take the last 3 months of demand, add them together and divide by 3. That's a moving average 3. That's of the last 3 months, average them together, that's next month's forecast. Or it might be moving average 6. Take the last 6 months, add them together and divide by 6. Exponential smoothing is a really, really useful method where it uses an alpha, a little Greek character, and you have to determine what alpha to use. It usually is around 0.1, 0.2, 0.3, so there isn't a whole lot of variability in that. But depending upon how strong, how large that alpha is, that is factored into your current demand, or your most recent period demand, and the forecast from that. So it kind of takes into consideration, oh, you were a little off last month. Take 30% of that 0.3 and put it back in. Excellent method. Seasonality, where we see a different pattern. We see that with fashion items, suntan lotion, beach items, gloves. Even within a day, you might see different things sold at different times. Like you sell more soda type drinks at lunchtime, less at breakfast, more at dinner. So there's seasonality, which means peaks and valleys across a time period. And that time period can be a day, a week, a month, or a year. Never more than a year for seasonality. So I want to see if there's peaks and valleys, and it's a repeatable. If I'm looking at a year, then I want to look at last year, the year before that, and the year before that, and see if I get those same peaks and valleys. If I do, I have a clear seasonality model. And then the other would be regression with trend. So instead of regressing and using economic indicators as my regression input, I will just use time periods, period 1, period 2, period 3, period 4, and it will set a trend line based on, are things increasing over time, linear trend, or are they decreasing over time? And I'll be able to just plug in some future period, like 10 months from now, what'll be my forecast. And those are very accurate in the short run, and they're so easy to calculate with Excel. So, speaking of forecast accuracy, or what's often called error in the forecasting world, recognizes no forecast is perfect. We're not expecting them to be perfect, but we want the best possible forecast so it is the most accurate possible. And depending upon which technique you use, moving average, single smoothing, double smoothing, exponential smoothing, all these different methods, some will work better than others with different items. And so we use this forecast accuracy or error measurement to decide which one performs best. So forecast error is very simply the difference between the forecast for the period and the actual demand. So we always have to look back in history and say, well, I forecasted that I would have, let's say 200 customers come at lunchtime, but I only had 180. So that would be, here's the formula, D, demand, your actual demand, 180, minus the forecast, 200. So your error is negative 20, which means I overestimated by 20, negative 20. It might be 20 positive, and that means that I underestimated by 20. So that error calculation is, and it's for a specific time period. Actual minus forecast. Always it's that order, D minus F. And here's what it looks like on a chart. The dotted line shooting out through the middle is your forecast. And the jagged line is your actual demand. And what we see is the difference between, and these are periods across the bottom, 1 through 11. We could say these are 11 months. The difference between the actual and the forecast is the error. Now there's 6 ways we measure it. And these formulas are pretty straightforward, but let me just touch on them and show you how these fit together. So, cumulative sum of forecast errors, or CFE. You're going to see this mentioned a lot in the book. It's going to come up in the quiz, probably going to come up in your assignment this week. CFE. So you just take your error each period and add them together. All of these are accepted, useful, working ways of measuring forecast error. But each one has its little ups and downs. And I used to lead a team of forecasters. We had 10,000 stock items we forecasted. And this was for an electric utility. So these were everything from nuts and bolts and washers to transformers and poles and feet of cable and feet of wire. There's a difference. And all these different items, 10,000 items that are used in the electrical system to bring electric from the substation to your home. And we use some of these, and I'll tell you a little bit more about them. Average forecast error then is the CFE. So if you added up the last 12 months is your CFE, you divide by 12. So it says by month, how much are you generally off? The challenge with the CFE is that some months you're over and some months you're under. So you got negative numbers and positive numbers. They cancel each other out and they basically disappear. So you could be horribly wrong each month, but they cancel each other out and your error comes back at essentially 0. So you just need to be aware of that a low number for error or average error can be a product of being horrible at forecasting, but they just cancel each other out, which is probably not where you want to be. Mean squared error, this is my #1 pick when I was working in the forecasting industry. Mean squared error is, again, by period, last month. What was your demand minus your forecast? The month before, your demand minus your forecast. But when you get your error, the difference between the demand each month and the forecast each month, and let's say it was negative 20, you square that. And so the negative goes away. So again, you have a little problem because you don't know if you were high or you were low. You just know you were wrong. But we liked mean squared error, and it was our #1 go-to for determining which forecasting method to use. Because if you think about it, if your error was 1 last month and you square it, it's still 1. 1 squared is 1. But if your error last month was 10, you square it, you get 100. And so our preference for mean squared error was because small error was ignored and large error was emphasized. So you really focused on where you were really wrong. So love that method. Standard deviation is our statistical technique where we look at the difference between your average error across the 12 months and the error each individual period, and then you square that difference. So it's just another way of coming up with it, not one that I've used. Mean absolute deviation kind of works, but remember what absolute means in terms of algebra. When you see those two bars, absolute means take the sign away. So that means your negatives are no longer negative, your positives are still positive, and when you add it all together, you end up with a sum of all of your error, and then you divide it by the number of periods in your calculation, so you get mean absolute deviation. Not bad. Again, I like the mean squared error because it emphasizes large error and minimizes small error. But mean absolute deviation is a great way to go. Now this one's really cool. This was my number 2 choice, mean absolute percentage error, because it takes the absolute value, takes all those signs away, it adds them up, and divides them by the demand and your n. But what's really cool about it, and the reason I liked having it, is when I was working with my planners, there were 10 of us on the team. When I was working with my forecaster and planners, we looked at mean squared error to pick which tool. But when my boss came in and said, "Oh, how accurate is your forecasting?" and I'd say, "Oh, well, our total average mean squared error is 325." What? It has no meaning. Is that good or is that bad? But if you ask, well, what has been the last 3 months, and you looked at the trend, then you could kind of tell whether you're getting better or not. But that number 325 or 4,000 or whatever the number, it has no meaning. Whereas when you do mean absolute percent error, or what we call MAPE, it gives you a percentage. So when the boss comes in and goes, "How's the forecasting going?" I can say on average we're 17% accurate. I mean, actually it would be 83% accurate. But at any rate, it's a percentage, and then people can say, "Oh, that sounds like you're doing pretty good." It has meaning. So let me just show you a quick example. These are 10 periods in history, so you can do last month, the month before, the month before, the month before. We just call them period 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is the furthest away. The actual demand in period 1 was 39. The forecast was 41. So remember, the formula is actual minus forecast. 39 minus 41, that's -2. The period 2, so 2 periods back, 37 minus 43, that's -6. And then let's just go to period 3, 55 minus 45, that's +10. So we know our error, and I'll just fill these in. Here's our error, -2, -6, 10. Always calculate error the same way. Now let's see how these work when we do the absolute. So absolute means remove the sign. Simple enough, they're gone. And then you sum that down, it's 81, you divide by 10, and now your mean absolute deviation, MAD, is 8.1. And the way this would work is, let's say this was a moving average 3 method. I'd say, well, hey, try moving average 6 and see if your mean absolute deviation goes down. If it goes down, then use 6. If it goes up, then stay with 3. So we use it to test out different methods to see which one works best, item by item. This is the MSE, mean squared error. So I take my error of -2, I square it, and that gets 4. -6 squared is 36. So again, the signs disappear. But large error, there's that 10, squared is going to be 100, so it emphasizes large error. We add those down, 879. We divide by the 10 periods. Our mean squared error is 87.9 over the last 10 months. Again, that number doesn't mean anything unless I do the same item and I forecast it using exponential smoothing. And I come back with a different MSE. And I say, oh, it's better. Let's use exponential smoothing. And here's the good old MAPE, the mean absolute percentage error. And you can see 5%, 16%, 18%, average 17% error. And if you remember, take the reverse of that, so it's 100 minus 17, so my accuracy is 83%, my error rate is 17. But that's how those all fit together. Pretty easy to do those on a calculator or in Excel. Now let's jump back to these judgmental methods that I mentioned. So there are good times to use judgment methods. If you have data, use the data. If you don't have data, or for some reason the situation has changed so that data is no longer applicable, then you need to use the judgment methods. So if I have a brand new product just being introduced, or I have a product that's being introduced into a new market. We've had it for a long time in other markets, but now we're going to introduce it in China. How's its sales going to be? I can't just take my US data and port it across. I may be able to use that demand pattern, but I need some expert opinion on what would be the potential demand in that new market. Sales force estimates. You can talk to your salespeople. They know the customers. They could help aggregate that together. Executive opinion. They're the bosses. They've been around a while. They know the industry. They've seen products introduced before. What do you think the market would be? Market research, the marketing people actually going out and doing focus groups and collecting data to look at what is the potential market for this product. Delphi method comes from our old mythology perspective, and that is basically ask the expert. So here we go. These are our mathematical methods: causal and time series method. So number one, I mentioned earlier, correlation and regression. So it has to do causality. The one variable is potentially causing the other. So as temperatures increase, air conditioner sales increase. As temperatures decrease, the sale of winter coats goes up, the sale of gloves goes up, the sale of scarves go up. So there's a relationship, there's a correlation. And if you know the demand for one of those items, you can use the correlation to estimate the demand of the other item. Regression, you did this in your statistics course. That's where you take a set of X variables, and it could be temperature, economic condition, number of children in the family, ages of the children of the family. You could put all of these things together into a regression and predict demand. And regression, you can do that right in Excel. Does a fabulous job with that. Naive and moving average, weighted average methods. The way all of these three work, naive says, look, just take whatever's last period and make that for next period. So it's just like if I was going to predict the temperature tomorrow, the high temperature of the day today is probably, let's say, 36 degrees. Say, well, what do you think it's going to be tomorrow? Well, it's probably going to be a whole lot like today. I'm going with 36 degrees. Chances are you're not going to be too wrong. Moving average says take prior periods and add them together and divide them to get an average. So I might take the last 3 days temperature or the last 5 days. So if you have something that's having small trends in its data where it's starting to trend up a little bit, it's starting to trend down a little bit, then moving average is a great way to go. And you have to do some experimentation using your error estimates, error calculations to say, well, should I use 2 periods, 3 periods, 5 periods? How many periods moving average should I use in order to balance that out? Weighted average usually takes 3 prior periods and it assigns a weight to each of those. So, and normally the greatest weight is on the most recent period, and then a little less on the prior and a little less on the prior. Those 3 weights have to add up to 1. But what it does is instead of just averaging the 3 periods and treating them equally, it puts emphasis on each one. So the most recent period might be 0.6. The period before that might be 0.3, and then the period before that would be 0.1. That all adds up to 1, and it puts more emphasis on the most recent period. Great method. Exponential smoothing requires the estimate of a smoothing constant, or what we call an alpha. It's the little fish symbol from Greek. And it takes a little experimentation. We actually used this, and it was one of our most successful and popular models, but I had to calculate what the smoothing constant would be. Turns out ours was 0.3. And then in research and talking to people, it seems like 0.3 is like the number one answer. But it should vary by products, but it usually varies between 0.1 and 0.3, 0.4, something like that. And what that does is it takes your forecast, your actual demand for last period, plus the alpha times your forecast. So it says, well, forecast error rather. So it takes into consideration, well, I was wrong last month, but I'm not going to just add that whole error in. I'm going to take a percentage, the alpha of that, and add it back in. So again, a nice method, but you gotta kind of just try different alphas to find the one that gives you the lowest error according to your error measurement. Seasonal methods, they come in two flavors, additive and multiplicative. And you essentially do is you look at your last 12 months and you calculate the average of those 12 months. And then you figure out the difference between each month's actual and the average. And you can either use that as an additive and just say, well, in May it was plus 30, so just add 30 every May. Or in June it was plus 60 and add 60 every June. That's additive. Multiplicative says to calculate that difference as a percentage each month and use that percentage to calculate your seasonality. And by knowing those additive factors or those multiplicative factors, it basically will replicate that pattern every single month into the future. So really good, reliable method, extremely easy to calculate once you get a look at the formula. Now, one last one, another very popular one, time series regression. We talked about regression a minute ago, but this is where we use regression, but the X variable, the causal variable that causes Y is your demand, is always the time period. And we don't use like months like 1, 2, 3. We use January was always 1, February is always 2. I'm sorry, should do that the other way. Yeah, we can do it that way, sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then put the actual demands in against those. And basically it'll create a trend line. And it might be fairly flat, it might be pitched up, it might be pitched down. And what that regression has calculated is how much your sales are increasing or decreasing each month. The challenge with using time series regression is it's linear regression, so it goes at that angle forever. So in the short term, it's extremely accurate. But the problem is if you go to forecast 3 years from now, you may not continue to grow for the next 3 years, and your forecast can be horrendously wrong. So time series regression, really great tool, short term, next 2 months, 3 months, 5 months. Don't go out 3 years using time series regression unless you're positive that your item, whatever you're selling, is going to continue to grow indefinitely, which I've never seen an item like that. Speaking of which, here's our demand patterns. Horizontal or stable. So this is our demand pattern always over time. So picture this as a year. And so what we see is the demand's up, down, up, down, up, down. These are really good with moving average methods, naive method, and weighted average methods, but mostly moving average and naive methods. Does a great job with this. Upward trend or downward trend. We started to talk about that, and this is where the exponential smoothing works well, but even more so the regression line with trend, time trend. We'll put a line right through this, and then you'll be able to say, well, 3 months out, 4 months out, 5 months out, and it'll just fill in that line going out into the future. Seasonal, I talked about before. This is where we're seeing within a year. So seasonality always looks within a year. You can also look within a day or a week if that's the way your business runs, where you've got Wednesdays are really high, Mondays are really low. Seasonality works in that type of scenario as well. But the seasonality models, multiplicative and additive, work out great in this, and it essentially will reproduce this pattern. Now, you see what's happening in this chart? We've got 2 years worth of data, which is great. So I can average those together, or I can blend those in some way and then calculate my seasonal additive or my seasonal multiplicative based on multiple years, which would be perfect. Cyclical, this is where it gets funny because cyclical and seasonal really have the same shape. They have valleys and peaks. But what's different is cyclical. We would never start to look at cyclical unless we were talking about multiple years. It's got to be a long time period. If it's anything less than a year, we're just going to use seasonal. All right, the hot topic of the day, big data and AI. So big data, our text defines it this way: large volumes of complex, I-added unstructured data to drive forecast. And that's what really gets most interesting with big data. It's not just that I have 88 years of data to look at, that's large volumes. But that 88 years has really no meaning for me. I'm only interested in the last 2 years or 3 years or 5 years. So volume really isn't the driving factor in big data. What makes big data interesting is the variety. So I've got customer preferences, I've got income levels, I've got family size, I have years of education, I got all kinds of different data points about people. And there's even more data these days because of all the social media data. Meta, Facebook can give us all kinds of data about people. Velocity talks about the speed of data, which again fits with all the social media data we have coming in. And I want to emphasize that word unstructured. And what that means, and this is where data scientists and big data come into play, is that we have data, but it's not easily like attributed like this person has an income level of this and lives in this much expensive of a house and has this many cars and has this many pets and has this many children. So it's very clearly attributable and mapped to a single person. Unstructured data is just it's just all over the place. Think of social media data. If you started to review social media posts associated with coffee, I mean, you'd have people using different words to describe it and all kinds of just noise. And big data analytics allows us to kind of make sense and find patterns in this unstructured data. Very useful when it comes to forecasting. Artificial intelligence has added a new layer to this, and really the part of artificial intelligence that's being used in forecasting is really machine learning. There's three types of machine learning. They mentioned this in the text. Supervised, because the machine, the computer, needs to learn from the data. And supervised means I go through the data first and I tell it where the patterns are and what the variables are that look interesting. And then the computer just tries putting it together in different ways, and it uses mean squared error and MAD and all those different error measurement tools to find out the best way to put the data together. Unsupervised allows it to go out and pick all the variables it wants to. So it might identify variables I haven't even thought of or wouldn't even consider, and it starts mixing them into the relationship to see what provides the best forecast. And reinforcement is just a modification on these two, and that is where the computer is given feedback on good models and the right things to do. And so machine learning has been a really powerful tool because it's been able to put things together and search through infinite volumes of data to come upon a forecasting model. Let's just even think of a regression, and it might put together 28 things that I would have never thought of, and it comes up with a perfect regression estimate, which would never happen, but a really good regression estimate. And the kind of getting down to my final areas are collaborative forecasting. This is where it really comes together. I successfully did this with one company, and we were starting to do it with another when I changed industries. But CPFR, Collaborative Planning, Forecasting, and Replenishment, means really not just saying, oh, well, the forecast ran, and we used the moving average 6 model, and it came out with a great forecast. So next month, order 500 of those. That's what forecasting does. It tells you how many to order. You order them, they come in. Collaborative planning, forecasting, and replenishment means taking that forecast and instead of just ordering them, working with your suppliers, because your suppliers might have information that you don't have. They might know something about new competitors coming online. They might know about some competitors that are going to go offline, which will increase your demand. Maybe they'll know about shortages in raw materials coming up. So having a discussion about my forecast, and this company I worked with, we would do a 6-month forecast, and we create that internally for all of the items we bought from that company. Let's say it's 25 or 30 items. And we would take that to them and then sit down with them and say, hey, this is what it looks like we're going to order for each of these items for the next 6 months. And then they would look at their production schedule and say, well, hold on. We've got some downtime coming up on one of those machines. So instead of ordering those in March, you better order those in February. So make a double order in February, skip March, and then in April, we'll get it back on order. So all this discussion, and what it does is it coordinates and collaborates, and it gives us much more accuracy because we take all these other factors into consideration to make small adjustments to our forecast, and then the stuff actually comes in when I need it. So it really does work, really great tool. So I hope that gives you kind of a taste. I know this was a little long, but forecasting is something I've really spent a lot of time working in, and it's such an incredibly important tool, and it's something that a lot of my students, when they graduate and they go out and take their first job, they're like, oh my gosh, they're asking me to develop a forecast for this. Do you have those old videos on how to do a moving average? I remember you talked about these. Where's that? And they go back to these videos and put it back together. So I hope this helps you get your head around forecasting and get started and do some problems.